Ooh. All right, where are we going?
First, we got to get settled.
Yeah, but I like to know where we're going.
Oh. You get them all excited in the back row, then.
Oh, they're not even listening to me right now.
All right.
It was more of a, hypothetical question. Our camera seems a bit out of focus.
Which one?
The main one, the main HD.
All right.
Ah, that's so much better.
Okay.
Thank you.
Yeah. Sorry, I was just in the middle of my system check here, getting set up.
Can't operate in this mode.
Oh, you don't like it like that?
I am not a, what do you call that mode? The wrong mode.
The wrong one. That's fair.
Yeah.
I think Danny likes to switch it up a bit, see how the other modes work.
Does he?
I don't know.
So once ROV is settled, wondering if we can do a white balance before we take off.
I'm setting up to do it right this second.
Oh, you're the best.
As we
Thank
speak.
you. Amazing.
All right, so what we're looking at here at the landing site is an area that's pretty heavily sedimented with probably some very fine calcareous and organic rich silts. See some ripple marks that show that there's water probably flowing either upslope or downslope. My guess would probably be downslope if you force me to choose. A little bit of loose
Can you zoom in?
All right, zooming.
And yeah, it looks like we're off to a decent start on this dive. At least the geology portion looks like it'll be easier this dive. So we are going to white balance the cameras and get some final things sorted.
A little closer.
Then we'll be good to go.
Sorry, what?
A little bit closer so I can fill more of the frame. That's my full zoom.
Oh.
Here, I'll go wide for you.
I see.
All right, let's try that there. So we still have the light. Okay.
Oh, I could push the camera out too.
Oh, that would probably do it.
Now you're gonna get too much.
Now you can probably go back where you were.
It's good?
Yeah, all right.
I wasn't for sure. That had a little bit of a tinge of not sure.
All right, I'm gonna black balance first. We're gonna go dark, so one moment.
Yeah, Robert, I'm seeing maybe a tiny bit of yellow in there. So you're seeing something.
Oh, I hadn't balanced yet, guys. Come on.
I know. No, we're not critiquing you. I'm just confirming his suspicions that it's not exactly the balance we wanted.
It was just the way Amber was saying it. That had she wasn't quite all the way happy.
Fair enough.
Let me see. How does that look? How does that look? That looks better to me. All right, I think I'm happy. All right, onwards.
Okie dokie.
Thank you so much, guys.
Can you pan me over there so I can see what I'm doing? All right, happy clam.
Good, thank you.
Let me get my ballasting right here.
Ew, there's like schmutz on my screen.
All right, where are we going?
We're gonna go 262. That sound good?
262.
262.
Sounds wonderful. Which way do I need to go?
You gotta turn around.
That way. Yeah. You good over there?
Yep.
All right.
Look at all those loose and angular rocks.
Ooh,
Ooh,
that's interesting.
It's like a perfect triangle.
I'm extremely interested.
Yeah, look at that. An
So
angular
you know,
rock.
Val, we reballasted, so we have a little more rock capacity. Not huge, not basketball-sized rock capacity.
Yeah, let's try to avoid that again. No objection from back row on that. Now let's look for something reasonable.
You don't want this loose junk, though, right?
Some of the loose stuff, actually, yeah, I would be interested in if we can find something that's about the right shape here.
Like the triangular bit? That looks kind of big, though, maybe.
That looks quite big. Let's maybe not do that one.
We can dream.
There was some very careful maneuvering of that rather large rock on the saw yesterday, and I like to try to minimize that for safety reasons.
Yeah.
Also,
You
so
splashed me when
we
you
don't have
poured
any
it out
back
of the
injuries.
box, too. We didn't really do that.
Yeah, I felt really badly about that. That was really cold water. I couldn't feel my fingertips. That's what happened there.
Oh,
And then you got to feel the cold fingers of the ocean.
Yeah. All right, but maybe something around here before we get
Yeah.
going, or?
Yeah, let's do it since we're here.
All right.
All right, let's
There's
see
this
what we
one.
have.
That's pretty angular.
Were you looking
That
at this
one?
one, Megan?
Yeah, that's the one.
Yeah, I kind of like that one too. Let's see what size it is.
Like 20?
It's on the big side.
Is
Maybe.
Maybe we
30.
get closer and then.
Yeah, let's get a little closer. There are a few good candidates in this area, so maybe. Yeah, that's on the upper limit of what I would usually go for. So let's settle down and take a look around here. We can poke at a few of them.
Is it almost that time, Val? That
It is
special
very
time?
much time.
It's a rock o'clock.
It is rock o'clock.
Alrighty, hi to any of our
What about
viewers
that
just
one
tuning
Hang
in.
on.
nudged in between there? I don't know, unless it's in place.
Somebody was asking a question, I think.
Maybe.
Oh, Val.
It might be in place.
It's Annette.
Yes.
Can you hear me? Okay.
Yeah, we got you.
Yeah, so
Yeah.
you're looking, I can turn on
Yeah,
the sampler.
That one in
once you
between
get the
those
rock.
two larger
Okay.
ones.
Yeah.
Yeah,
The
that
laser's
looks
almost
nice.
Yeah,
on
once we're
it.
clear of the sediment, right?
Yes.
Okay, perfect. Sounds
Okay.
great. Did you want a water sample around here at all?
Yeah. I don't see any, well, it's an area where we see some biological diversity, I think.
Oh.
Okay,
Yeah.
sounds good. We'll keep eyes open for that.
Okay.
I can't see the basket. All right, that's good.
All right.
Is that-
So
what
the
do we
one,
think? That's probably going to be in place, though.
the one that
don't
the
know.
lasers are on, that looks loose. It's angular. Could we pick that one up and take a look?
Yep.
Awesome. Thank you.
We can try.
We can try. It doesn't look like it's glued down to my eye. This all looks like loose rubble here.
Yeah. I know how these
And when the
things
seamount
work.
gives you rubble, you go with the rubble. All right, our shore team is also very ready for this dive. They're getting their coffee ready.
Ooh.
Oh, it's in snappy happy mode here.
Yeah.
It's good force 4.
Yeah.
Oh,
There
it's
you
like
go.
perfectly square.
That's
Wow.
beautiful. That is a beautiful rock. I'm
very
so excited about that rock. Can we
Lots
keep
of
it?
angles.
Can we take it home?
Give it a name.
I'll leave that to you.
Wow.
Yeah.
That's the
is
kind of
beautiful.
angular that I like to see.
It is a square.
Oh,
There's
what
something
And it
about
looks like it might have a polychaete or something on it.
Wanna
What is
zoom
that?
in?
Oh.
Zooming?
Yeah, let's get a quick zoom on that. Maybe that'll come with it. Maybe we'll have a traveler.
It's a barnacle, I think.
Okay, Steve, we're getting you a bio subsample too.
Is a barnacle
for
in the
the
family
price of one.
Scopelidae.
Ooh, nice idea on that, Megan.
Look at the color at the bottom. Oh, wow.
So that's actually
where's this
some of
going?
the igneous rock itself.
Starboard?
That's some surface alteration that you're seeing. So we're actually seeing part of the rock exposed without crust on it, which really helps. It makes it a lot easier to sample these things on the seafloor.
Ooh,
So we actually see what we're getting.
Yeah. Oh, that's fantastic.
Yes. A lot less ambiguous. There we go. I'm getting all my words right today.
Yeah.
Not really.
Well, we do know it's rock o'clock, though.
It is. We'll have a rock o'clock again later if all goes well.
Did you get stuck?
Wait, what am I missing here? I'm missing a camera.
Yeah.
I want that one. I don't want that one.
Oh, that one. Yeah, that's the one.
And then I want that.
Oh, sample cello. Yes.
Can we squeeze that in a little box?
I think it'll fit in a little box.
What?
Let's go for A.
I like it when they fit in little boxes. That's great.
Ooh, that might be a wedge.
That
wouldn't be
looks
the
like-
Nah.
Not going to fit.
We were a little ambitious on that.
We
we
It
can
wouldn't be
try.
the first
If
time
it
that we'd
goes in,
crowbar to
it's never
sample
coming
out.
out.
Yeah, let's put it in the bigger one.
Yeah, let's be safe on that.
E, worth the shot.
All right, it's an E. That was aggressive.
All right, thank you, Robert. Okay, why is Google Drive not working? That's weird. There's my dive plan tab.
Go ahead, Bridge.
And this is
Okay,
sample
the-
029.
Robert, the bridge said that. Did you hear her? Cool.
I'm going to start multipuffer pumps 1 and 2, if you
Okay.
can make a log of that. Thank you. I'm sorry, 0 and
Well,
1.
0, 1. Yeah.
0 and 1. Roger.
Multipuffer.
That was sample number
Hold on, I'm not
029.
getting, hold on.
029.
I need to restart things. Hang on.
Okay.
Not yet?
We are standing by on
Okay.
multipuffer.
Okay. Confirming pumps 0 and 1. Nope.
Is 1 not starting?
I'm sorry, it's not starting.
Okay.
Which one is not starting? 1 or
Neither of them.
Neither.
Oh,
okay.
neither of them.
Yep.
Okay. Do we need to stand by while you try to reset?
Yeah, stand by, please.
Okay.
Yeah,
Roger that.
we're standing by anyway. So the bridge just let us know that they need to do a test on the jet pump. So we're gonna drift here a little bit.
Okay. Sounds good. So I think that's I think that works well with what we need to do back here. Thank you.
Nav.
Who's calling me?
Can you please drop a pin for sample 029?
Yes, the pin is dropped.
Oh, okay. Thank you.
Do you need that long?
Ooh, okay.
It appears pump 0 did start.
Okay.
Okay, so if you can record that from a minute ago.
Yes.
I'm starting pump 1 now, confirming pump 1 is also on.
Excellent.
Looks like I just needed to restart the software. Thank you.
Oh, yeah. Okay.
Is it? Okay. Oh, Megan, we have an incoming question. Did Herc get some new arm technology? Would you have any knowledge in regards to that?
New like manipulator arm technology?
Yeah, someone made a comment on the arm is moving way faster and more precisely than before. I was like, oh.
Oh yes, we did get a new craft arm. So
Brand new.
brand new. Our starboard arm is new and shiny.
Ooh.
It's very nice.
Yes.
Someone has good eyes.
What happened here? Oh, there we go.
Alrighty.
Yeah, our old arm, we'd been rebuilding that for quite a while.
Yeah.
It was time.
I think it was the oldest operating craft manipulator.
I would believe it. I believe it.
Yeah, they eventually get old and creaky just like we do.
Mm-hmm. Sometimes DW4 ain't enough. Alrighty, welcome to any new viewers just tuning in. Questions are still open on nautiluslive.org for anyone just joining us. Ooh.
Well, it looks like we're drifting in the direction we actually want to go, so that's cool.
Hey, I'll take it.
Oh, well, I thought we were going 262, you said.
Yeah.
We're going,
Yeah,
that
we're
way.
going that way.
Drifting that way.
Yeah, but the ship is drifting.
Oh. Roger.
Yes. we as the humans are going in the correct direction.
Yeah, fewer navigational moves.
The standpoint of
Yeah, the you. We are all Herc together.
We are Herc,
We are
yes.
collective.
Are we the Borg? Assimilating.
Does that make us a Saphonophore?
Oh,
Yeah.
there you go.
We all have different jobs working together.
One of those specialized ones, not like one of the ones that can just kind of remake itself.
Yeah. little single bell ones. Or
Yeah.
like boop, boop, boop.
Yeah. I like that sound effect.
That was very good.
Ooh.
So these lavas look like they're in place. Stack of some lava flows that just kind of interweave together as they flowed slowly downhill.
Yeah, these look a lot different from before. That is so cool.
Yeah, so these are lavas we'd also have a really hard time sampling. And these are probably the source of a lot of the debris that we were seeing further down slope at our landing site.
Yeah.
So what we picked up is very likely near in place. And some of the very high angularity on the rock gave that away too. So it likely didn't travel very far downhill.
Yeah.
Probably came from somewhere in this vicinity. So on old seamounts where everything tends to get kind of glued back down to the seafloor because all of that mass wasting and weathering happened, probably tens of millions of years ago. Yeah, you pick up what you can get. Usually that's going to be the stuff that's not quite in place anymore.
Yeah.
On the younger seamounts where we don't have this incrustation problem, at least not to this degree, it's easier to wiggle a piece of lava out of an outcrop that it was in place on.
Yeah.
So the sampling strategies will differ depending on what kind of substrate you're working with.
So does the shape of this, does this kind of tell like how the lava flowed out in a way almost, or?
It sure does.
Yeah.
Yeah, so what we see here underneath these really well-developed ferromanganese crusts, you can see how things are kind of lumpy, and in some cases it looks like things are kind of wormy in shape.
Yeah.
So these are pillow basalts all stacked together, and these are kind of little lava flows that just kind of wiggle their way down slope.
Yeah.
And they just kind of form these very small little tubes, and they freeze at their toe. But there's still a lot of lava moving through that tube as it goes downhill.
Yeah.
And eventually that hydrostatic pressure builds up inside that crusted over pillow tote, and it'll crack, split open, and you'll get a little bit more that flows out before it freezes against the really cold seawater again.
Oh,
And you just kind of rinse, repeat, and it does that all the way downhill, and it kind of forms these sort of rounded bulbous features that stack on top of each other like this. So we call them pillows. I wouldn't use them for resting. They're not actually that comfortable.
Go ahead, Rich.
And they also contain, didn't you say, heavy metals as well the other day?
The crusts do.
Yeah.
Yeah.
Heavy metal crust pillows.
Well, it's the ferromanganese that has a lot of the that has higher concentrations of those heavy metals, and so that's what makes them economically interesting in some areas, depending on what kinds of metals are incorporated. But inside is
so they're done with their testing,
a core of basalt.
but we're gonna start kind of swinging underneath the ship, so we should get moving. Adelance is on her way.
Sounds good.
No,
Okay.
Go ahead, Rich. I think we can hold the position, and we're actually drifted in the direction we wanted to go, so we'll just go that way. Thank you.
no shopping though.
Yeah, no shopping.
Don't worry, I'm not gonna beg for any
we already went shopping.
We'll go shopping later.
We're doing an impromptu video transact.
I don't think this will be the most exciting photogrammetry, unfortunately.
Well, we're just getting to the exciting part of the dive by getting closer to the slope.
We sure are.
Yeah, and usually at the beginning of our dives, we choose a landing site that is comfortable for the ROV, generally somewhere a little flatter, and that way we can get situated, and it tends to be sedimented and have loose rocks, which the geologist seems to like. And then I like to kind of, fast forward through this part and get to the exciting stuff with all the coral.
I don't know. I think it's all exciting.
It's all exciting. Yeah.
Ooh.
Oh,
is
there's
that
something.
Yeah.
What is
There
that?
Oh, it's a dead sponge.
Stop.
Yeah.
Oh.
And there's a sea cucumber.
Yeah, so we are at a depth right now where we may not expect abundant communities. So we are a little deeper. We're a little bit below 2,700 meters. So as we get shallower, hopefully we'll see we'll see more communities.
Yeah.
Been yanking on you? Maybe. You're all right.
Bull shrimp. Alrighty.
So when you do this, you should look at the winch, and then you can kind of eyeball what you're doing. Looking over there is not as good, but see what's happening with the winch.
Okay.
Getting kind of low here. Don't go down. You're already at 10 meters. 9 meters. So see that view? See that you're coming over the ridge there?
Alrighty, welcome our viewers. I see viewers from the United States, Canada, Germany, United Kingdom, Australia, New Zealand, Norway, Netherlands, France, Colombia, and Austria. Welcome. If y'all are tuning in from the YouTube live stream, recommend you go to nautiluslive.org to send us any questions you have. We're currently exploring a seamount that has never had any dives previously done before in the waters of the Marshall Islands. So we're super excited to see what we find biologically and geologically.
And yeah, this seamount has a name. I believe it is pronounced Lawanji. I might not have that completely right.
Val, do you know?
Yeah, that sounds pretty right. Lewanjao.
Okay.
Lewanjao, yeah.
Oh.
Lawanji.
Mm,
Thank you.
no worries.
Thank you.
Alright, so that's an area of pretty thick sediment that we're looking over.
Yeah.
I'm looking for sea pens, and I don't see any.
Where is it? Almost like an undersea desert. Like little sand dunes.
I'll think for here.
Is this the kind of terrain that was expected for us to come down here? This is very cool looking.
Yeah, we're at the edge of a slope that we're going to be going up for most of the rest of the dive, so
Yeah.
this isn't too surprising here.
Yeah. Oh, wow.
That's what I was looking for.
Oh, wow. Ooh, team, are you think we're good for any introductions for any new viewers? Yeah,
Yeah, I think so.
All right, yeah. I guess I'll start it off. My name is Giselle. I am a Science Communication Fellow from San Antonio, Texas. When I am not on EV Nautilus, I am a STEM educator at a museum called SAMSAT.
All right, I'm Val Finlayson. I'm the 8 to 12 watch lead and the geologist on the ship. So you'll hear me talk about rocks a lot. The rest of the time on shore, I work at the University of Maryland at College Park as an isotope geochemist. And I work a lot on mantle geochemistry and on volcanoes like these. So the samples that we collect, they go back to my lab, and I work on them there.
Great. Hello, everyone. I'm Luisa Dueñas from the National University of Colombia. I'm based in Bogota. I'm a biologist. I'm also here with Ocean Census, and I'm part of the science team.
Good morning, everyone. My name is Hovil Darko. I'm from the University of the South Pacific. I'm the data logger, and it's good to be here. Let's get it rolling, shall we?
Yeah,
Absolutely.
In your front row, my name is Megan Putz. I am the navigator on this watch. When I'm not on the ship, I'm a deep sea biologist at the University of Hawaii at Manoa.
I'm Robert Waters. I'm in the Hertz seat. I'm OET's facilities manager at our shore facility in Los Angeles, and I work on all the electronic systems for the ROVs.
Hi, my name is Levi's. I am the ROV engineering intern. I'm on the Atalanta seat, and I'm onshore. I'm a mechanical engineering student at Columbia.
Hello, I'm Amber Flynn, the video engineer, and I'm based in Los Angeles as a cinematographer.
Me? Hi, I'm Annette Govindarajan. I'm a biologist, science co-lead on this cruise, leading the eDNA sampling with our multipuffer sampler. And when I'm not on the Nautilus, I'm a biologist at the Woods Hole Oceanographic Institution, where I study deep sea biology.
Ooh, awesome.
And I hope everybody appreciated the guest appearance of our wonderful little shrimply friend, who is our tour guide.
Cameo there.
I was highlighting our little friend. So cute. That's a very beautiful red.
We don't have any starboard, port and starboard lights. Where's the port and starboard lights? Okay. Where is it? Uh-oh. Switch, says me. Huh.
Oh, is that our same shrimp friend, or is that a different shrimp?
It is. It might not be the same individual, but it is the same kind of shrimp.
Oh.
It's a shrimp in the family Aristeidae.
Oh, wow. So graceful. Oh, Annette, could you tell us more about eDNA and why are we collecting that for this mission?
Sure. Well, eDNA refers to environmental DNA, and that includes little fragments of animals, that tissues or cells that get sloughed off, or in their fecal pellets or gametes, that these little traces contain genetic signatures. And so if we filter the water, we can collect these traces and then, in a forensic style genetic approach, figure out who's there. So it allows us to sample the environment without actually, for biodiversity, without actually sampling the animals themselves. And so what we've got on Hercules now is a new large volume sampler that can filter water in situ. So this is really helpful in traditionally, when we want to take water samples, we do it with Niskin bottles, which have limited water volume, and there's a limited number of bottles. This allows us to sample both larger volumes and more efficiently.
And so when you're taking those samples, does the level at which you take them in the C column, does that matter a lot?
Oh yeah, so absolutely. So when you look in the, we've done some work with my colleagues, Dana Yerger, with Mezabot, that's a mid-water robot.
Atalanta's passing you.
On previous Nautilus cruises where we've explored
I gotta get this message out.
the distribution of eDNA from animals with depth. And you know, I think when if viewers had been watching Hercules' descent to the bottom, we passed through the water column and we would sample the animal signatures in that water column, and there's definitely strong variation in the communities with depth.
Yeah, and I was like,
Yeah. Thank you, Annette. That was awesome. Oh my gosh.
Well, now we're hoping to do the same along the seamount. So as we sample
that's
close
the one.
to the bottom,
That's
but
the
as
best
we move up
page.
the seamount,
This page.
it'll be really interesting
I
to
wanna
see
use
if our
this
results
page.
indicate zonation with depth, which what I'm hoping and expecting that we'll see.
Ooh, and what is zonation for any viewers who might not know what that is?
Oh, well, so we might see different types of communities associated with different depth ranges. For example, on these very deep depths, 2,000 meters or so, might be different than what we're seeing near the seafloor at 1,000 meters. Right.
Oh, wow.
Yeah.
Oh, exciting stuff.
Thank you.
It's kind of like solving a mystery.
Yeah, it's like a lot of comparisons. People like to compare it to a crime scene because we look at, basically, you can think of it as genetic fingerprints in the ocean. So, and we can use these samples to look at anything from corals to fishes and even to the microbes, the microorganisms. So
some ocean forensics.
Yeah, absolutely.
So front row,
Awesome.
if there's a point where at the end of this move where you might be able to pause, I'm thinking about trying for a sediment sample here. Maybe using one of the PushCores. It doesn't have to be stratigraphically intact.
Okay.
Because it looks like this is going to go on for a while.
Yeah.
So this
I'm
might
not
be...
sure how sticky this sediment is. I'm not sure if it'll stick in the tube, but we can certainly try.
Okay.
Okay. New and improved? Tell me more.
Yeah.
You're on mute.
Sorry.
It's okay.
So we have an assortment of tube cores on here. So an experimental one that's on there. I don't think we've tried it yet. It's one of Dan's creations. It's a 3D printed insert in the tube core. It has like fingers.
Okay, so it opens up as you push down,
yeah,
but then
you
it
push
closes.
in, they open, and then it closes. You know.
Oh.
Do we want to try an experimental sediment sampling?
Yeah.
I'm kind of curious.
Yeah, I am too.
Ooh,
Let's
fun,
try
fun,
it.
fun.
It's also the hardest tube core to do.
Well, you should have told us that up front.
Well, because it's experimental.
Yeah.
Gotcha.
Of least interest in the order here. So
Okay.
they're easier from the front to the back, right?
Yeah. Okay. Pilot's choice.
Well,
Hard
we'll
mode.
give it a whirl.
Okay.
But
Excellent.
also, I haven't, driven it a bit, so I haven't done any tube cores in a bit.
Okay.
Yeah.
Yeah. Let's
So
let's
I
give it a
might
shot.
flail a bit.
That's okay.
We'll see.
Either it works or it doesn't.
So where are we at?
I think we're almost settled out from our move. So,
Alright.
if you pull ahead, I think you'll be good.
Okay.
Table 1.
So I'm going to pause the sampling while we pull up the sediment cores so we don't get sediment. So once we get
Right.
to this, I'll let you know when I'll keep
Okay.
it going until we select the spot.
All right. So is that like an end of those pumps or just a pause?
It'll be a pause.
Okay.
Thanks.
Yeah, and we're pausing the pumps so that we don't clog up the multipuffer.
Right, exactly. We don't want to get all the sediment in there to
Yeah.
clog up our filters.
Those filters hold, what do they hold?
Yeah, so they're very tiny pore size, 0.2 micron. So
Wow. And inside those filters is where we'll find the eDNA
Yep.
for later?
that's where it ends up.
Oh.
Along the lines there, the exhaust for the slurp pump is pointed somewhere back there.
Yeah.
I don't know if we look to see, we could, maybe move it if it's potentially pointed at the
At the
micropuffer.
multipuffer. Okay.
You might want to look at that.
That is a good point. Should we make a note in the red book?
Yeah, note that in the red book. All right, are we settled?
Yep. Looks like.
All right, you want to kill the poofer?
Okay. Okay. I'm pausing the poofer.
I think your instrument's just been renamed to that.
Oh, I love that. It sounds so cute.
It does.
Why isn't that going down?
Ah.
Does it go up? Does it do anything?
It's going down.
Oh, okay. Just slow-mo.
It's just really slow going down.
All right.
There you go.
I don't think it's all the way out. Either you want to extend.
You want to extend out?
Yeah. And then you can go down some more. All right, I'm going to set down in the mud here.
Table 1, have you turned off the multipuffers yet?
right, Levi.
Yeah.
These buttons here, these purple things, are used to switch the camera modes. So I'm going to be switching between looking at yours. Yeah, you can go ahead and switch it back to the dive custom. All right, so I'm asking you to switch that when I'm ready. Can you pan over there?
I'm all the way over.
Oh. Dang it. All right. All right, can you switch that?
Whoa.
All right, and then we want to go drawer out.
Drawer, stubber, open.
That's good right there. And I think it's this one.
Did you make it a different color?
It's the
Oh, just the farthest one?
farthest one, yeah. It's very snappy, even though the grip force is at 4.
It's new and improved.
Yeah.
So see that purple?
Oh
we
yeah.
got?
Oh, yeah.
Look at that.
It's like a little Easter egg.
Okay, well, I'm going to take it right here, actually. So I
Yeah,
don't
it's
have
easy
to,
there.
Sounds great.
I don't have to go out front and fiddle about. Okay,
So cool.
you're getting whirlwind effect here.
You want to secure that thruster?
I'll just dial it back a little bit.
Okay.
So you get the twisters back there. See that? See
Yeah.
Oh,
Yeah.
whoa, yeah.
Yeah, yeah.
it?
Little mini tornado.
So yeah, the deck chief and I on this expedition and I we sailed together last year on a dredge cruise. And we were talking about maybe designing a dredge with a similar kind of concept to it, just made out of like rebar or something because we destroy 3D printed plastic. Dredging is a little bit more harsh.
All right, here we go. Maybe.
Oh.
Can't see what I'm doing.
Oh.
Need more beans.
Hey, there's something in
I was
there.
gonna say, it looks like some sediment did go there.
Yeah.
For anyone just tuning in right now, we're doing an experimental move to collect some sediment.
So what will you do with this sediment?
So we have a scientist ashore, Sarah Kahanamoku-Meyer, who requested some sediment samples. Sarah's a geologist.
Is that enough?
Whoa!
Sort of. Oh, that's a lot of sediment. Look at
That's
that.
amazing!
And
Not in a hole
also,
yet. Just have to point out.
yeah, Sarah does some geology, and I think some. I think she's also looking for some critters in there.
Here comes the
It's the real challenge.
fog bank.
Yeah, this is always the hard part.
It'd be easier if you could zoom in, but you can't.
Oh yeah.
Am I crooked there? What am I doing?
I think you're like just on the lip. Needs to go back a little bit.
Dang it. can't see.
There you go. You're almost in there. If you could just dangle it a little bit, it might fall in.
But the jaw's so snappy.
Yeah.
Oh my God. All right, I'm gonna see.
Oh, there you go.
Oh.
Yeah.
Oh.
Don't spin. Don't spin.
Perfect.
Oh, very nice.
Oh.
We need to adjust.
Needed a little tap.
It's got a creep to it, too.
030.
What sample number are we on? 032 is up on the board. 032.
Okay.
Yeah, because we've got the 2 multipuffer samples.
Incredible.
All right, just the one?
Just the one, yes. Thank you.
That was
beautiful
awesome.
sample.
That's amazing.
I don't know about all that, but...
Nicely done, nicely done.
All right, I think we can turn on the multipuffer.
Oh, don't turn it on. Don't turn it on.
So I'm going to resume 0 and 1.
No, don't do it. It's all dusty back
Annette,
there.
could you put your mic closer up towards your mouth? There you go.
It's all
Thank
dusty
you.
back there still. Don't turn it on.
Okay,
Wait
multipuffer
for
stand
other-
by, I think.
Okay,
Yeah, I think
It's-
Robert wants to
it's
get us
all-
out of the area.
Yeah, it's all dusty back there.
okay.
Got it. I think in Atalanticam I'm seeing some weird pits ahead of the ROV. I can't tell if they're like burrows or not.
Oh yeah, you're right.
Yeah, I've noticed that you can, from that downward angle, you can see a lot of really interesting shapes and forms in the sediment, and then when you come upon them in the HD on Hercules, you don't see them at all.
Yeah, it's got to be
Yeah.
the lighting angles.
Yeah.
There are critters here that we're not seeing.
Oh, absolutely.
Yeah.
There's some like cool echurans and things that live down here, and they'll like send out their proboscis and make these spoke trails.
All
Oh.
right, switch me back to dive special. Yeah, there you go.
Special. Okay, let's make a move. Yeah.
Yeah.
Sounds good.
Bridge now. Hi, we're ready for a move. We would like to go 30 meters to 62 at 0.3 knots. Yep, thank you.
Okay, can I resume the sampling? Is that good for you guys? Okay.
Yeah, I think
We're
it looks
moving,
better right back
so-
there.
Yeah. Okay, so I'm resuming 0 and 1. Thank you.
Sounds good. Thanks, Annette. I'm wondering whether we might see any xenophyophores around here.
We may. It seems like usually we don't see them a lot in these like highly rippled sediments.
Okay. So they tend to be in areas where the current's not as strong?
Yeah.
Okay.
Well, because they have to build their tests and they're pretty fragile.
Yeah, yeah.
But xenophyophores are pretty cool.
They are. They're really strange.
They're like the largest single-celled organism.
Ooh.
They're also multinucleate, so they have like multiple nuclei within their cell. Yeah.
What?
So does that have any sort of evolutionary advantage that we know of?
I don't know that much about them.
Okay.
Well, let's look at that cucumber.
Yeah.
Ooh.
I think this is a different one than what we've seen so far.
Yeah, this is different than what we were seeing yesterday.
Yeah.
Can you zoom in?
Okay, zooming.
Oh, what are those things sticking out?
But they're
Tentacles.
just, you know, party streamers.
Party streamers.
So this is likely in the family Laetmogonidae.
Oh, wow. Oh,
And
that's so cool.
they're characterized by these long projections along the body.
Right. I don't want to set down and make dust, so
Yeah.
right, stop that.
That is so cool.
And you can see right through the tissue and all the gut contents, all
It's
that sediment.
quite purple inside.
Oh,
Not
yeah.
so much on the exterior.
Yeah. Is the
Except
dark
for its
purple
beak.
the head?
Yeah, so the darkest part, that's the head with those like feeding arms. And so they'll pick up little bits of sediment, put it in their mouth.
Oh, that's so cute.
And they just walk around on those little projections that act as legs.
Wow. Kind of reminds me of some caterpillars I've seen back home.
Kinda, yeah.
Do sea cucumbers have any known predators out here?
Not really. No one really wants to eat them. They're not particularly tasty.
So they're not that delicious. Okay.
No. But you'll often see like polynoid worms associated with a lot of these larger sea cucumbers. They use them, I think, mostly as shelter, and as the sea cucumber cleans the seafloor, those animals can also gather food and just hang out, I guess.
That sounds like the life.
Yeah, I mean,
Yeah.
everybody's pretty chill down here on the seafloor.
Just chilling.
Right.
All right, perfect. That's good, some good pictures there of our little cucumber friend.
All right, great.
If
Shall
we see
we-
enough, we can make a salad.
Ooh.
Oh my.
Are there sea tomatoes?
Sea tomatoes.
Haven't seen any of those yet, but maybe.
Well, when you see one, we can name it.
Ooh,
Yes.
yes. Be excited to make that salad.
Yum, yum. All right, shall we get a move on then? Try to find some corals?
Yep, we are in the middle of a move.
Beautiful.
Atalanta is working on getting going.
Okay. Just waiting for the swing.
But yeah,
Yeah.
we're going to make some tracks here, I think.
Sounds good.
Okay.
Yeah, so we are planned for about a 14-hour dive on this one, so we've got plenty of time to cover plenty of ground. But we are hoping to see some corals and maybe do some photogrammetry transects today. So that's one of the big goals that we want to get among our other sampling objectives sometime during this dive. So we're going to try to make our way back to some harder substrate.
Oh. What are photogrammetry transects? What are those?
So that's something that one of our other lead scientists, Fanny, is interested in doing. And what she's looking to do is take this imagery and with photogrammetry, you can take images and create three-dimensional projections of them by basically, it's a software-based thing that you can do to take imagery and extrapolate a 3D image out of it. Just looking at the differences in perspective that you get from image to image.
Yeah.
Yeah, and we can do that to high resolution, and she can use that to survey and analyze coral colonies in detail from that kind of three-dimensional, more interactive imagery.
That's so
She
cool.
can probably give you a little bit more detail on what exactly that entails, but yeah, it's something that's becoming more possible with the increases in camera quality, camera capabilities, and resolution, and the software that can generate these kinds of images.
Yeah.
So it's a really cool new tool that's coming online.
Yeah, it kind of makes me think of the possibilities if you were to implement like VR headset goggles. You can be able to
that's
tour.
Exactly it.
Yeah.
Yeah. Another OET SCF, Daniel Kinzer, has done a little bit of work like that.
Oh, wow.
Yeah. So he has a VR model of the Nautilus.
Oh, well, I gotta check that out. That sounds awesome.
Yeah. And I have some geology colleagues who will do photogrammetry of rocks, so you can have a digital model of a rock that you can rotate around in space.
Whoa.
Yeah.
Oh, that sounds so fun.
It's very cool.
I would do photogrammetry on all my rocks I have at home.
I'd see you doing photogrammetry on all the things, to be honest.
Probably.
We did that on a World War II airplane, and it's really cool because you can zoom in, like, so it's very, it works well for they were looking for the missing in action pilots.
Yeah.
And they can zoom in and try and like identify items. Like you wouldn't see them just flying by doing the original survey.
Yeah.
But afterwards,
wow.
you can zoom in and like identify specific things, you know?
Oh, wow.
That's amazing.
Yeah.
That's such a powerful tool.
Yeah.
Yeah, and it also opens up doors to making like survey and study of things documented in this way more accessible to a bigger community, because not everybody can travel from point A to point B.
Yeah.
So you can just send a digital model to them if that will help them do what they need to do.
Yeah.
Or just open up the ability for anybody to access some of these sites and explore it virtually. Yeah.
That's incredible. Oh, it's crazy how far technology's come.
Done right, it opens up a whole new world for all of us.
Wow.
It's using the same technology as they use in video games, you know?
Yeah.
The Unreal Engine 5 is what we're using to process our stuff.
Yeah, the stuff that we did a couple years ago over near the main islands of Hawaii. Oh, is it time to get up?
Sorry. No doubt a spam call too.
We're at sea, why are we getting phone calls?
So weird.
It is, it's so strange.
Yeah, I leave my phone in airplane mode. No one can call me.
Leave me alone, I'm working at sea.
Yep. I get a lot of spam calls.
Yeah.
Me too.
I think that's maybe a feature of the new administration.
Oh, the calls I get are absolutely a feature.
Yeah.
I just don't answer my phone anymore.
Leave a voicemail.
Yeah. If it's really important, leave a voicemail.
If it's
If it's
important,
really,
I
really
already have your
important,
number.
call again.
Yeah.
Or text me, I see it. Unless you're a spammer, then leave me alone.
Yeah. No spam allowed.
Well, there's a do not call list for a reason, but not everybody believes in that, so it is what it. Anyway, how about them sediments?
Yeah, the sediments. Tell me more. You know my favorite geology term is silicious ooze.
I love that term.
What?
Geology has so much good terminology.
What does that
Best
mean?
terminology.
Yeah, and silicious ooze just rolls off the tongue in the most delightful way.
It's so
Silicious ooze?
It is a legitimate geological term. We actually dredged some last year.
What is it?
It's silicious ooze. We've gotten the lithified version of it. It's a very silica-rich, like, substance, basically, that oozes along the seafloor, and it does eventually lithify into stuff that's a very silica-rich rock. And yeah, you can dredge it up sometimes, and it's very, very difficult to cut. Because yeah, once it kind of lithifies, it turns into something very similar to like an agate or like a chalcedony. Yeah, it's very quartz-like. Arguably similar to opal in some ways too, although without the iridescent effect.
Oh wow! See, now I was thinking like Teenage Mutant Ninja Turtles, like the green ooze.
Not quite, but getting there. I'm not really sure how it forms, though. Isn't there some sort of biogenic aspect to it, we think?
It's mostly biogenic.
Like
by
diatoms or something? Yeah.
Oh. So like diatomaceous earth, sort of, but like
related to that, yeah.
But the deep sea version.
Oh.
So it's very hydrous until it hardens into something that does not make rock saws very happy.
Oh.
It's a good way to go through a blade.
Oh, jeez. So you trial by fire.
You just wear the blade out. We went through a couple of blades trying to cut through a couple of pieces. We went through a blade trying to cut through some pieces last summer when we found some.
Oh, wow.
They're kind of large.
Yeah.
But we wanted to get a look at the interior so that we could document it, look at anything that might have mineralized within it.
Mm-hmm.
Yeah.
Do they kind of have the look of like an agate? Like, are there rings and bands, or it's more just kind of...
You don't get the banding, but you get that kind of cloudy color, and you can get some like patchy multicolor variations in it. Yeah.
Ooh, very nice.
So it looks like an unbanded agate.
Yeah.
Yeah.
Ooh, like the mossy agates, kind of?
I don't know about mossy agates in particular, but just like kind of regular
white.
Oh.
Kind of just not very heavily feature-rich textural agate. It's just sort of like the more plain ones.
Yeah. Oh, okay. Okay. Very cool.
Sometimes you get little dendrites that grow in them though, and those look like little patches of like what folks call mossy agates, but you don't see as many of those. It's where you get like a little crack or something after it lithified, and the seawater leaches in and starts depositing like ferromanganese or something.
Yeah.
Yeah.
Oh wow.
Do you have different rock saw blades for different rocks?
You can, but for hard rock, we pretty much just run a diamond blade for the tile saws. For smaller samples, we will use these little small, like, precision oil rock saws. You can use those to cut really small pieces and cut things that might be a little bit more sensitive to water or need low contamination kinds of settings. So there are some specialized ones, but for oceanic work, we tend to mostly run with a diamond blade because that will cut through most things. It's pretty reliable.
Wow. What was the most surprising cut you've ever made into a rock sample you found?
There have been a couple. One that was kind of interesting was NA138 back in 2022. We pulled up a few rocks off of Argonaut seamount up in the Liliocalanes. It's this very low-lying seamount that kind of looks like one single rift zone with a little summit. So we dove on it. We got up to the summit, got some samples there, came back up, and we one of the rocks from the summit area. I put on the saw. I got through the ferromanganese crust pretty easily, and I hit the interior of the rock, and all of a sudden, just the saw gets really, really loud, and it was really hard to cut into the substance. And that tells me, yeah, I was into some really resistant, really silica-rich material. And like after a while, you know, you can see the saw starting to throw sparks, which told me, yeah, okay, this is very silica-rich.
Whoa.
It took us probably half an hour, 45 minutes maybe to get to the point where enough of it was cut that I could just chisel it the rest of the way open.
What?
And I open it up, and yeah, it's this. It was either silicious ooze, or it was hydrothermal, like heavily silicified, like remineralized lava, maybe that erupted through carbonate or something. And yeah, it had some signs of metal mineralization, so places where some metals had concentrated in it. And just I've seen that before in the field in terrestrial areas.
Yeah.
I hadn't quite encountered anything, at least of that size, at sea before.
Yeah.
And same hotspot track, different location last year. Yeah, we found some similar stuff too. So there's something going on with that hotspot where it's just conducive to generating things that later get remineralized, and it could be related to, you know, the area and, you know, developing carbonate caps, or something with how it's developing hydrothermal systems, or how it's circulating fluids in the melt zones. So there's something geologically really interesting there to figure out, and we haven't had the time or the funding to work on that quite yet.
Yeah.
We're hoping to, though.
That sounds like a really cool mystery to solve.
It does.
Yeah.
I also like it when you cut rocks open of this age and you get little bits of fresh glass that are still sometimes preserved in the rims. From when the lava quenches against the seawater. It doesn't get time to crystallize, so you get what we call glassy rinds. It just quenches so fast that the melt just freezes into a glass.
Oh, wow.
So those are rare. I don't know if we'll see one on this expedition. We might. Sometimes they come up, but those are always nice little surprises when you open up a rock too. And we can do some extra work with that because the glass can preserve things in a different way than a regular lava can.
Yeah.
So that's valuable material, and we always keep that, and we let colleagues know about that in case they want to work on it. Yeah, because you can just do some specialized work. You can get some information about volatile elements that normally just in crystallized rocks they escape.
Yeah.
In glass can hang on to that.
Yeah. Oh,
Yeah.
wow. So
If it's in good enough shape.
Like a time capsule, almost.
A little bit.
Yeah.
That's basically what rocks are.
I guess, yeah, I was going to say, most rocks.
Little time capsules.
Yeah. Is that glass rind like a certain color, or is it just like a clear?
It's usually black or dark brown.
Oh.
Yeah, so it's basically obsidian, volcanic glass, and
Oh, that's so awesome.
yeah, it has a distinctive visual look to it, distinctive appearance. So
There's a jelly coming
we
up.
can tell.
I can see it in the cinema.
Oh, yeah.
A little friend. Hello.
Oh yeah, can we get a little zoom on this one?
This is so cool. Oh.
Hello, friend.
Rob, can we try the cinema cam zoom?
Are you asking me? Do you got control? You can do what you want with your cinema cam.
I can do it.
You're free to.
Oh, you can see its tentacles really well in CinemaCam.
Yeah. How?
They're not so visible in HertCam.
Do you got control back there?
Yeah, I think she does.
This is a crisada.
A crisada?
What's a crisada?
Which one's cinema cam, actually? Is that the lower one?
This lower one is just that one. I think that's lower, and this one is upper.
So where is it?
Oh, I think they're talking about this camera.
Oh, okay.
Oh.
Were you able to get some shots?
Bonk.
Oh, bonk. Oh no.
Oh
Too close.
It's, you know, that's going to be tough.
Yeah.
Sorry. All right, moving on.
Moving on.
Oh. Alrighty.
So Levi, you've been quiet. I'm putting you on the spot. How's it going driving Atalanta?
It's pretty smooth right now.
Yeah. So this is your first time as one of the pilots, right?
It's my first expedition. It's my second dive.
Awesome. You're doing great.
Thank you, thank you.
For anyone pursuing being an ROV pilot, what kind of advice would you give for them to get started?
For me, I just applied, I reached out, and I also did a lot of projects. I was in Made ROV for a couple of years.
So what's Made ROV?
It's this pretty cool competition. You make these little ROVs, so like not as big as Hercules or Atalanta, but you can, it's pretty much a very similar system.
Oh, do you have any special kind of sensors on those robots?
On ours we had ultrasonic, and we also had a few weird ones.
Weird ones. Weird how?
Yeah.
Weird, maybe not, weird wasn't the right word, but we had some cool features. Usually in Made ROV there's like a special challenge each year. So I'm blanking right now, so I don't really
That's okay.
remember, but if I do.
Yeah, just shout if you think of it.
Yeah, be like, oh, I remembered.
But you got to do things like go grab hooks or hoops or something on the bottom and bring them up or whatever, right?
Yep.
Yeah.
It's like a robot agility course.
Yeah.
Oh,
yeah,
that's fun.
I think they have different challenges every year.
You got to train your robots.
Yeah.
That's so cool.
And that's tough to do underwater because it's not just forward, backward, left, right. You also have up, down, and buoyancy issues to deal with, and all sorts of physics involved.
It's so much fun though. I know for where I work, SAMSAT summer camps, we do the Sea Perch program. So they're more basic ROVs. We just do like thrusters, some soldering, PVC, but still so much fun to work with.
Oh yeah.
I was a mentor for Sea Perch.
Really? Oh, what was that like?
Yeah. It was pretty cool. I mean, the problem with Sea Perch is you only have a $20 budget. You have the
$20?
Yeah, you have the basic Sea Perch kit.
Okay.
And then you only have $20 to work with to try and come up with something.
Wow.
It's super challenging.
Novel, you know?
Yeah.
So like you could 3D print some parts for it.
Yeah.
But you got to account for like how much the material costs.
Right.
Whereas Mate's like more, I don't know if they even have a budget limit.
Yeah.
I see.
So I also work with a Mate team at a high school in LA, Palos Verdes, and they have a more robust budget.
Okay. More than $20.
They accounted for inflation.
Yeah.
So it's like 40, right?
Like maybe 20 years ago, $20 would buy you something interesting.
Yeah.
Yeah. There's also still Radio Shack then.
Oh, Radio Shack.
I miss Radio Shack.
Me
But
too.
like, could you find things that you found around, like, or
that is a legit engineering thing, though. You know, like a big part of engineering is you have to be cost effective, right?
Right.
So
Yeah.
you
You
keep
do,
the
yeah.
bill of material costs down. Like, you know, they're always trying to make things cheaper. So
of course.
Yeah.
I've taken a look at high voltage boards on mass spectrometers. I see the cost effectiveness happening there sometimes.
That sounds scary.
I'm just gonna leave it right there.
That might not be a place you want to cut costs.
Ideally no, but I have seen out of spec resistors soldered in where they were working and then not working.
Yeah.
And then you replace them and they reduce the high voltage output by half because we just matched ratings and didn't realize what happened until we compared it with an identical one. That was some cost effectiveness.
So as a geologist, you're in monkeying with the electronics in the mass spectrometer?
That's when I take the geologist hat off and I put the geochemist hat on where you have to be able to do a lot of your own diagnostics to fix stuff, and we can work with the engineers at the manufacturer back at the factory that made the instruments.
Yep.
But we usually can't afford to fly them out for everything, so we have a lot of skills that we pick up along the way. So.
Do they provide you with drawings for this stuff?
Yeah, we get schematics.
Yeah.
We also use multimeters a lot for these kinds of repairs. If it's really complicated or really dangerous stuff, then yeah, if we have an electrician available on campus, we'll bring in the electrician to help out.
Oh, that's good.
Yes, yeah. Not every university has a physics shop these days, though.
Yeah.
We're fortunate to have one at University of Maryland. So we have an electrician we work with there pretty often, and he is so good.
Huh. Yeah, that's something that's happened over time is that, things don't come with schematics anymore. It used to be back in the day, you'd buy a TV set, and you could get a full set of schematics for the TV set.
Yeah.
And you could actually go in and fix the thing.
Well, they don't want us to fix it.
Well, I mean, now there's a switch back the other way, right?
Right.
That people are demanding the ability to fix things, right?
Mm-hmm.
Like you want your phone, so you can replace the screen on it. Or the battery or whatever.
Right.
Yeah. What's cool is I've heard some shops recently opening up that where they just focus on helping people learn how to fix things like your toaster or a fan.
Yeah.
Yeah, so I'm like, we need more of those. That sounds fun.
Yeah, I'm all about right to repair, I don't like it when things are designed to break and be thrown away.
Yeah.
When it's something that you should just be able to fix. Like, I want to be able to replace the battery in my computer or upgrade the memory. I don't like having everything soldered into one thing. Yeah. It drives me bonkers.
So along the lines of the ROV competitions and stuff, there's maker spaces. I don't know if people know.
Yeah.
Oh, yeah.
That's a very cool thing. So it's a place that they, a collective that they have machine tools and like 3D printers and things, and you can sign up for fairly low cost and go in and use those things that would be like too expensive to just own on your own.
Right.
Yeah.
Yeah, not everybody's going to drop $2,000 on a 3D printer for their house.
Yeah.
I built my own.
I have one of those really old little monoprice 3P printers. Yeah, it doesn't do anything special. It was not totally tuned up out of the box, so I've swapped parts in and out of it. I might start messing with the firmware at some point. Those are fun.
Ooh, what is this?
Looks like a crinoid.
It's a knot sediment.
It's not sediment.
Yeah, look at that.
Do we have two knot sediments?
Can we zoom in?
2 knot sediments.
Zooming.
Enhance image. Oh, look at that.
So this is a crinoid or a feather star in the family Pentametrocrinidae.
And these swim.
Oh, they do?
Definitely can swim.
Yeah.
Oh.
Very graceful.
Yeah, occasionally we'll just see one swimming through the water column. They're very cool when they swim.
Oh, wow.
I love the way they undulate their arms.
Yeah.
That is so neat. I like the two different colors going on with this one.
Very ombre effect.
Yeah. Who is she? Love that. And what causes them to swim away? Like, is it them just being scared, or is it a defense mechanism, or feeding?
In shallow water, they can swim to go from place to place. Usually when we make them swim, it's a defense mechanism to escape.
Yeah. Oh, wow.
So something eats them? What would eat them?
Other animals might nibble on them.
Oh.
They can also regrow their arms. They are echinoderms, so like sea stars, they can regrow their arms. So sometimes you'll see them missing an arm, or an arm is a lot shorter than the others.
Yeah.
But these ones have 5 arms only, but some crinoids have many, many, many arms.
Oh, wow.
Yeah, sort of like that Brisingid that we saw during the first dive that had some shorter arms.
Oh, yeah.
All right, so I've heard it pronounced 2 different ways. Is it Brisingid or Brisingid?
I guess it depends on who you ask.
Yeah.
I think with the Latin words, we do it whatever way makes us happy, because it's a language that we're not using anymore. So I don't know if there's a particular right way. I'm sure certain people have certain opinions.
Yeah, like the GIF versus GIF debate.
Yeah,
oh, yeah.
like that.
What's the difference between talus and scree?
So
Geology question.
You know, that's a good question.
I'm going to turn off pumps 0 and 1 and turn on pumps 2 and 3. If you could note that in the data log, please.
Okay.
Okay, pumps 0 and 1 off, pumps 2 and 3 on. Thank you.
Oh, there actually is an answer to that, Robert. Scree is loose and small. Talus is larger and not nearly as loose as scree.
But you never hear undersea geologists refer to stuff as scree.
Typically, no. I think talus we kind of use as a catch-all.
Yeah.
Yeah.
Why is that?
Keeps terminology a little simpler, I guess.
Huh.
Also, talus. I don't know.
It's fun to say
I
talus.
like the word.
Well, usually when we see those talus fields, are big, bouldery.
Yeah. We do tend to see a lot of larger debris in those.
Oh, wow.
All right, so we're moving past waypoint 2 and making our way over toward waypoint 3 and trying to get up on the slope of the feature that we're surveying today. Although at the moment we are in the middle of a large sediment field, so it's not the most exciting view, but there's life somewhere in that sediment.
In the secret sands.
Yep. Although we are hoping to see some coral colonies today.
And are those usually found in sediment fields, or we're trying to get across
I'm sorry, I missed part of that. Can you say that again?
Oh, so are corals usually found in sediment fields like this, or are we trying to get across this to get to?
Not as frequently. You tend to they tend to want to have a firm attachment point, so they usually like harder substrate.
Yeah.
Yeah.
Yeah, usually the only corals you'll see here are sea pens. So I know we've seen a few umbellulas, or I've spotted some, but not as many as we were seeing yesterday.
Yeah.
There's also the protoptilums that we saw yesterday. I haven't seen any of those today either. But other than the sea pens, a majority of our corals need hard substrate. And if we had some like cobbles or boulders, we would probably see a bunch of coral on top of it.
Yeah.
Mm-hmm.
Oh, crossing my fingers that we see some.
And sea pens, in addition to having some cool names, the attachment point that they have, their little foot, it's called a peduncle.
A peduncle.
Yeah.
What? Oh, that's amazing.
So biology has some excellent terminology too.
Truly, that's a really good word. I love that.
Mm-hmm.
Peduncle. So we got puffer, peduncle, sea tomato. Lots of good words for today.
Silicious ooze.
Yeah, oh yes, the silicious ooze.
It's delicious.
Is it?
No, it's not.
Oh,
it just
It's delicious. It's delicious.
Exactly.
that sounds like a cereal brand. We need to get on top of that.
That would be a little too crunchy for my taste. I like having teeth.
But Val, do you know what different rocks taste like?
Yes.
Yeah.
Geology uses all 5 senses.
Truly does,
I also know which
doesn't it?
rocks not to lick.
Yeah, some of the hydrothermal vent blocks, I don't think you want to be licking.
Yeah. No, the ferromanganese crust, definitely not.
Yeah, the heavy
Yeah,
metals.
anything that is more sulfide, anything that likes to bond with sulfur, that you want to stay away from that because that usually involves heavy metals too.
Ooh.
Anything that's like reasonably radioactive, also no.
Yeah.
Probably.
So
Reasonably.
no uranium minerals.
What if it's delicious? Is that
Don't do
worth
it. There's certain lead-containing compounds that have a sweet taste because of the lead, and
Oh, what?
yeah, so you have to keep those away from kids.
Oh my gosh. Wow. I was just about to say, besides salt.
Hang on, ops question.
Yep, okay. Pump 0, 134, 131. Pump 1, 170-711. Thanks.
So Amber, it looks like we have some new cameras that we're using on Herc these days. You want to tell us a little bit about some of those?
On Herc or in the control van?
In general, also
Yeah.
in the control van.
On Herc, and Robert, maybe I'll just speak better
Nope.
on this one. We have what we call the wide field camera array, which is if you are looking on satellite 3 in our little 7 box, that kind of top quadrant there, that is our like ROV upper camera, and so that's a great view for the pilots because it kind of gives like a spatial awareness of where their porch is, and it's a nice wide view. In the bottom right little quadrant on Sat3, there is I believe that's the cinema cam, correct me if I'm wrong. Or is that the ROV lower? Let me look. They look similar, because they're very similar in their placement, but there's also one that they use for the stills. Let me...
Yeah, I'm actually not sure looking at the two.
Yeah, they're very close. Let's see.
So those cameras are being multi-purposed, right? Because those are all part of the wide field camera array, which is what we were using to get the what do you call
Photogrammetry?
it? Photogrammetry.
Yeah.
Mm-hmm.
Yeah. So those are all part of the photogrammetry system. It's
So
just a-
reconfigured for
yeah.
just piloting. Yeah, so the one that is in that bottom right is the RV lower camera. And then when we're doing samples, you may see that we've got some cameras that are looking at where our Niskin bottles are triggering so we can make sure that they're closing. We have some that are looking at the bioboxes, and that's just really to help the pilots to have spatial awareness of where their arm is when they're reaching behind themselves. It's wild to me that you're able to, in this 3D space with not having cameras in every single spot, be able to figure that out spatially. So
Yeah,
kudos.
what I'm looking at now is doing like what you have in a car where you have the bird's eye view.
Yeah.
Like we get multiple cameras and then fuse them all together with AI
Yeah.
to make a bird's eye view so we can see all around the ROV at once. So
That's cool.
That's my
Yeah, my uncle has that in his car.
yeah.
It's
Yeah.
really wild.
Yeah. Well, so you can buy the system with all the cameras and the smarts. We just got to get them in underwater housings and deal with all that
kind of like the
sort
Waymo
stuff.
vehicles that we see
Yeah.
driving around in LA.
Oh my gosh, that sounds so scary.
Well, they're using that technology you're talking about, right? Where it's the
Yeah.
Yeah.
kind of, yeah.
Yeah. Well, I mean, most cars you buy now, the better cars anyway, have all that
Yeah.
in them.
Yeah.
Yeah.
So it's pretty, ubiquitous. You can just go out and buy that stuff.
Sure
You
is.
just got to get it inside the housing. It'll go down to 4,000 meters.
Yeah, that's right.
Yeah, and then here in the control van, we've got some new cameras up that give watchers, viewers a much better view of what we're doing here in the control van.
Yeah. Everybody
Yep.
has eyes on them now.
I'm not a big fan of those. Let's see that one.
Yeah. The nose cam.
Yeah.
No.
Oh,
Good way to describe it.
It sounds like we need to adjust some angles on some things.
I remember I had to do a Zoom meeting with the nose cam on. Oh, it was so bad. I was like, oh god, I'm so sorry, y'all.
Nose cam? I haven't heard this term. Is it just like because it's up your nose
Yeah.
a bit? Yeah. I think we've adjusted most of them so they're higher now.
Yeah.
Gotcha. Okay.
That's good. It was on a laptop, and I was like, why is it at the bottom of the
Yeah.
screen?
I recently took a Zoom call from my tablet and had it on the side, and the camera on the side is fine. It's just, for whatever reason, every few seconds, I'd set the camera so that it would see that the screen was rotated horizontally, and it would adjust that way, and then it would adjust itself back to vertical. So I spent most of that meeting sideways.
Defying gravity.
Yeah, some weird software glitch. It's like, well, you're just gonna have to deal. I can't just keep rotating this iPad around.
Yeah.
I only have so much patience for that.
Yeah. To stay on task.
Where are we going to find the rocks at?
Hopefully uphill.
I mean, the lines are getting closer together, so
All
hopefully soon. But
Yeah, and I don't want to ask if we can speed things up too much, because I'm worried all of a sudden that's when the rocks will appear.
yeah, I've been making 50-meter moves.
Yeah.
Which.
At 0.3?
Yeah, we're moving.
0.3.
Yeah.
Okay.
Yeah. We've covered a lot of distance.
We have. It's just this sediment field is going on.
It's a lot longer than we anticipated.
Yeah.
So far.
Well, I'm okay with going faster, but just keep an eyeball on the sonar, maybe.
Yeah.
Look for
Yeah.
Would
We've
Bridge
gone
be?
almost 400 meters.
Wow. Would Bridge be amenable to maybe bumping it up to 0.4 knots? I don't know.
I don't know if that's going to really make a difference.
0.5.
Yeah.
0.5? I'll do what you say, Robert.
Well, just pay attention to the sonar and see
Okay.
if we can see.
I mean, it's quiet.
lumpy
There's
bits.
nothing there.
I'll let her know.
Yeah.
Oh, wow. What's the furthest distance that Hercules can go?
Yeah, I think Steve's getting itchy for some bio.
Yeah.
Yes.
I don't blame him. I'm getting itchy for it too, and I'm the rock person.
We haven't really seen any rocks either, so.
Well, I'm always
Right at
itchy
the
for
start.
rocks, so that's just
You
like
did
normal
get your
existence.
rocks right
Yeah.
at the
I
start.
did get a
I know,
rock
we did
early.
get a really nice one.
Yes, and I am
It's
very
so
pleased about it.
It's very
square.
beautiful rock.
Very cube.
Yeah, it should be like
And the
Minecraft
colors.
rock.
Oh.
And it was very clearly a lava, so I'm over the moon with it. But I'm always a little itchy for rocks, so that's just like normal existence. But yeah, when I'm starting to think, man, I really want to see some corals, we need to go see some corals.
I always worry when we pick up rocks that there's no basalt in the middle.
Me too.
Mm-hmm.
I've gotten my success rate on in trying to infer lithology underneath the crust. I've gotten pretty good at that, but still not batting 1,000. Never will. You think you've got the perfect rock, you can cut it open, and it's like a phosphorite or something.
Yeah,
And
it's like full of brown mud.
sometimes it's full of brown mud. Sometimes you just zip through it with the saw, and if you're cutting through it too easily, you're like, yeah, unfortunately this is not what I was trying to pick up. But you document it, you archive it, and it's there in the collection for somebody who will one day want to work on that kind of rock.
Yeah.
So it still has pretty high research value. It's just not what I'm hoping for my project.
Yeah.
Right.
That's all.
In Palau, we were having a really hard time getting real rocks.
Oh, hard rocks? Yeah.
Yeah, hard rocks.
Yeah.
They're all very soft rocks.
That's not a real rock.
Dirt clods.
The geology there was very strange.
Really?
Yeah, I didn't know how to describe it.
Yeah, unfortunately, I didn't tune in on those dives. I had too much else going, and it can be hard to pay attention from the isotope clean room.
Fair enough.
Yeah. But yeah, I'll go back and check out some of the highlights and see if anything pops out.
Yeah, for sure.
Yeah.
So what's the difference between soft rocks and hard rocks?
It's sort of a casual
scale?
term that we use. Yeah, and it literally is. Some rocks are harder than others, and yeah, Megan's right. It's the Mohs hardness scale, so it has to do with the kinds of minerals and that make them up, and how the rock is cemented together if it's a sedimentary rock. So, sort of broadly, hard rock, as we call it, is more igneous, or technically speaking, since these are altered metamorphic rocks up to a certain grade. Soft rocks are more like sedimentary rocks, or things that are really heavily altered or replaced like a hyaloclastite or something, or sediment, phosphorites, versus lavas. So it's
Interesting.
sort of it's just jargon.
Yeah.
Yeah.
I love it.
So I like the hard rocks.
Can we zoom
They're
in?
literally harder to break apart, harder to cut.
Yeah.
Can you zoom in?
Hard
Yeah.
mode. What is that? Huh?
What is that?
Is it a rock?
Is it a rock?
Is it a xenopiophore? No, it's not.
It's definitely a rock.
That might be a bit of pumice or something.
Yeah, it looks kind of full of holes.
Yeah, we get pumice rafts that come in from some of the arc volcanoes along the Pacific Rim, and they erupt and they form these rafts that can float and kind of travel for sometimes thousands of miles across the Pacific, and eventually they get waterlogged and sink to the seafloor. And that looks like a piece of pumice from a raft.
Wow.
Yeah, and we actually see them on most of the dives that I've done throughout the Pacific. We've dredged them up in some places before, so they're just these little travelers that come in and settle out across the ocean.
Yeah.
But they come from arc volcanoes, so like the Kamchatka volcano, well, not those, Marianas Arc, the Aleutian Arc, the volcanoes along Tonga.
Yeah.
Yeah.
So the arc volcanoes, that mean like a violent eruption, or? Or what does that
They can have more violent eruptions, but these are volcanoes that form in response to two plates converging on each other.
Oh.
So where you get subduction zones where the oceanic crust is pushed below continental crust or below a different oceanic plate that's just more buoyant. And as that downgoing slab, the one that's going down into Earth's mantle, heats up, it dehydrates. So it releases water and volatile content out of the slab as it gets heated up and starts transforming under high heat and pressure.
Yeah.
And when you add water and volatiles to the overriding lithologies, that fluxes them. It's a flux agent, so it makes them melt more easily. And so you start generating melt, and that works its way up through the crust and forms volcanoes.
Wow.
Yeah.
Oh, that is so cool.
Yep.
And then with those pumice rafts, like how long do they float for? Like how long do they float?
I don't know. Depending on how permeable the pumices are, how easily water travels into their interiors, that can be weeks to months, maybe years in some extreme circumstances, but weeks to months is not atypical.
Oh, all right. I was over here thinking like hundreds of years, like.
Doubtful.
Yeah.
You can't keep a ship floating for hundreds of years without maintenance.
No, this is true. This is true. Oh. Is that little shrimp kind of floating?
But yeah, the pumice rafts, they just ride around on the currents, go where they go.
How cool. I just know the pumice stones from the ones they sell for your feet.
Thanks for that note, Steve. Steve's noting in Science Ashore chat that we're starting to see some reflections about 100 meters out on Atalanta, which means we are coming up on something potentially different.
Oh.
Or at least that's at an angle that reflects back to Atalanta.
Oh, wow.
So we're coming up on that slope that we want to traverse up.
Yeah, well, the slope is increasing.
Yes.
Slowly.
We are getting sounds back from ahead of us, which is a good thing.
Well, that's part of the slope increasing noise. You're going to get more return off the bottom. So.
Ooh.
Which is what we want to see.
The angle of the dangle.
Yep. Exactly.
I haven't heard that in a while.
Yeah, it applies.
It does, it does. I use that at least once a week back home.
So we were pulling into Rabaul in Papua New Guinea, and the volcano was erupting, and we were getting ash and pumice on the ship.
Oh, that's a mess. That stuff's hard to clean up.
Yeah.
Oh, jeez.
And there were some people that went up the volcano, and they did a hiking trip up the volcano, and it erupted the next day, and like was throwing
that's crazy.
They got lucky.
stones out.
Yeah, you have to be careful with that.
You're like, I almost didn't die.
Yeah, like if it's the kind of volcano that's more prone to explosive eruptions and you know it's active, that's probably not the best idea.
Yeah.
No.
If it's like Kilauea or something, as long as you stay out of the caldera, you can hike on it while it's erupting and you'll be totally fine.
Yeah, I've done that in the Galapagos.
Oh,
yeah.
Oh, wow.
Yeah, that's another one that has, for the most part, more gentle eruptions.
Right.
Yeah. Oh, that must have been beautiful.
That was amazing. Yeah. I didn't do the Rabaul mountain.
Oh, we have a good question. Somebody's asking, is all pumice from volcanoes?
Yes.
Oh.
But yeah, it's usually associated with specific eruptive styles.
Mm-hmm.
So it forms when you get lava that gets a chance to degas and form bubbles in it, and that makes
really
it
going
buoyant.
very fast for going fast.
We're moving.
Very cool.
But yeah,
Usually formed through more
I don't know if it hasn't stopped, but she's
explosive
just
or like
kinda
fountaining
walked
activity.
along.
You can get different kinds of pumice.
Yeah.
Yeah.
Wow.
And eruptive products that are that are also
It just also
similar
feels
to pumice.
slow when there's nothing cool to
Yeah.
look at.
Right.
That'd be cool to see an eruption one day. On the bucket list for sure.
It's cool. Yeah, if you get the chance, go to Big Island. Kilauea has been having episodic eruptions that involve some high fountaining. And that actually produces some pumice-like products. So one thing they're getting a lot of right now that blows around
There's a fish.
downwind.
Yes.
A fish.
A fish.
Oh, a fish.
Yeah, one of the eruptive products that we're seeing a lot of right now from these high fountaining episodes is closely related to pumice, and it's something called reticulite.
Reticulite.
And it's very bubbly lava, so it weighs almost nothing. And it's this sort of green golden color, and it's a lot of very thin-skinned bubbles. You know, it looks like suds, except it's volcanic glass.
That's amazing.
Yeah.
In the dirt.
What is
You want to try to suck the fish?
What?
It's really small.
What is it? It's so tiny.
Is that a sample
Tiny,
request?
yeah.
Yes.
Okay.
It's a wee little fish.
Yeah, you just go up and suction it up.
Okay.
It's gonna
What?
float in there.
Well, we have all jars.
It's a cusk eel.
I mean, we have all jars open. We could give it a shot if you want.
Are we stopped? We're zipping.
Oh, are we in the middle of a move?
We're
Well,
we're
I'm
just
out in front, but
yeah, he's out in front, but
we can fiddle for a second.
Okay.
We need
Let's
we
give.
need jars set up and all that good stuff too. But
Okay. Yeah.
I don't have that on this.
Let's give it a shot, and then we'll make it up to this sonar reflection afterward. Steve agrees.
5. We're on 5.
5 sounds good.
All right, can you go porch out?
Porch out.
Are we still seeing the fish?
Yeah, it's
Yes.
just ahead of you.
It's kind of just floating there.
This needs calibration. All right, where is it?
You gotta look up.
Ah, there it is.
Where?
It's right in
Right
front,
quadrant.
like at
Oh.
the top of the screen.
It's
Oh
a
my
little
God.
out
You
of
might
reach
have to
right now.
fly forward.
It does look a little out of reach. What a strange fish.
Maybe we can try and drive by Slurp, you know?
You just suction forward.
Yeah. We'll just leave the suction on.
Yeah,
and
leave the suction
I'll drive
on.
the nozzle to the fish.
Yeah.
Okay.
Okay.
Ooh.
Suction's on. So yeah, there it goes.
Oh, that looks much better today.
Can we zoom in
Yes,
with
it
the
does.
camera as
Copy.
we go here?
Yeah.
Are we getting swirlies in the jar? Yeah.
Yep, we got swirlies in the jar.
And can you get,
More
we,
zoom?
we need to get close zoom, so you gotta, is that all the way over?
I just don't want to lose your nozzle.
Okay.
There you go.
Wow.
He's not in the jar yet.
All right.
Wow.
It's
That's
there.
how you do it.
Oh,
There you
it's
go.
in the
There
jar.
it
It's
is.
in the jar.
Yeah, that worked.
Well done.
Very well.
Nice flying, Robert.
Oh my gosh.
We were doing this in Palau.
Yeah, it didn't go as easily.
So do we have an idea of what kind of fish that is?
That was a cusk eel. It
Okay.
could be a porrigatus or a starts with a T. The name is eluding me right now,
Okay.
Wow.
but I will give that to you. Is this sample 35?
Yes, it is.
Yes.
Yeah.
Yes.
So he's in the jar?
He's in
Yes.
the jar.
It's in the jar?
We
It's
saw
in
a
the
tail.
jar.
Nope.
All right.
Do we want to rotate off of that jar?
Yes, let's rotate off the jar. Yeah, you can see the tail.
Oh yeah, look at that.
Go. Rotate jar. There we go. Number 1.
Okay.
I'm watching that sonar reflection get closer.
Can you suck the porch back in?
Yes, fortune.
And camera down and all that good stuff?
Yep.
Oh, I need to put the arm away better here.
Okay.
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 Rail bucket. Rail.
No, gotta get it.
All right, I got a zip ahead.
Sounds good.
We got more lumpiness. We got bright lumpies.
Oh, there's a
Ah,
little
some
bit
brighter
of
lumpies,
specks.
yeah.
Oh.
So we're getting some stronger reflections now. If we're lucky, maybe that means there's a little bit of harder substrate coming up, or just substrate.
There's some bright spots in the
Yeah, yeah.
There's maybe.
Yeah. This is sediment. It's technically not substrate, depending on who you ask.
Is this rock here?
Yeah, there's
some other
something ahead.
Yeah, starting to get some rock.
Yeah,
There's
there we
some
go.
rocks. Okay.
So I guess we could
We
go
can
back
slow
to our
down.
standard.
Okay, let's go
Yeah.
back to our standard.
operating
Oh,
procedure.
here we go.
That was quite the expanse. That was what, almost 500 meters of just sediment?
Yeah.
Yeah, that was a lot.
It was a really long
So-
way.
Mm-hmm.
I'm very glad we picked a longer track for this one.
For the multipuffer, I think this is a good time to transition to the next sample set. So I'm turning off pumps 2 and 3 and turning on pumps 4 and 5.
So we looking for rocks again, like collection, or just?
Not
move
here.
on?
These all look like they're in place. So I would say let's move on. Let's try to get above the sediments a little bit more.
Right.
Did you get that in the data log?
Yes, I did.
Thank you.
Awesome.
Well, looks like there might be a little coral in the rock straight ahead.
Oh, sure enough. Yep. Corals spotted.
Yay.
It's about time.
Coral
Zoom
time.
in.
Hopefully
Zoom
one
in.
of many more to come.
Yes.
No, it's dead sponge stock.
Oh, it's a sponge.
Oh.
Never mind.
A dead one.
All right, Carrying on.
We got sponged.
Moving on. So, question from the public
Tenuous
chat
cephalus.
is, oh, is that the fish?
That's the fish.
Okay.
Tenuous
Oh.